To understand how today's climate differs from the past, we need a long-term perspective, stretching back thousands, even millions of years. However, modern instruments like thermometers and satellites have only been in use for the past 100 to 150 years. So, how do we study Earth's climate history beyond the era of direct measurement? We turn to climate proxies, natural recorders that preserve evidence of past temperatures, precipitation, and atmospheric compositions. These indirect data sources are essential for reconstructing non-anthropogenic climate change, meaning changes that occurred before significant human influence. Tree rings provide annual climate records extending back hundreds to thousands of years. Each ring represents 1 year of growth. The width and density of rings can reveal information about temperature and moisture conditions in a given year. For example, wider rings generally indicate warm, wet weathers, while narrower rings suggest cold and dry conditions. Tree ring data is highly resolved, even seasonal in some cases, but limited to regions where long-lived trees grow. Moving to corals, coral skeleton grows in layers, and their chemical composition can reveal information about sea surface temperature and ocean chemistry over time. Scientists analyze isotopes and trace elements in these layers to reconstruct ocean climate conditions, often over hundreds of years. Corals are especially valuable in tropical regions where tree ring records are sparse. Moving to speleothems, these are mineral formations found in caves. Like corals and trees, they grow in layers. The oxygen isotope ratio and trace elements in each layer provides clues about past rainfall patterns and temperature. Speleothems can span hundreds of thousands of years, helping us understand past variability in regions with few other proxies. Ice cores are drilled from ice sheets in Antarctica and Greenland. Each layer of snow compresses into ice that traps small air bubbles, preserving ancient samples of the atmosphere. By analyzing the concentration of greenhouse gas, such as carbon dioxide and methane, along with isotopes of oxygen and hydrogen, scientists can reconstruct both atmospheric composition and temperature going back 800,000 years. Ocean sediment cores accumulate over millions of years at the bottom of the sea. These layers contain microfossils, minerals, and organic materials that reflect past ocean temperatures. Sediment core provides one of the longest continuous records of Earth's climate, often spanning tens of millions of years. They allow us to study major transitions such as the Ice Age, interglacial periods, and global warming events in the distant past. Beyond the visualized proxies, there are other techniques also covered in the SCR curriculum, for example, pollen records, lake valves, and borehole temperatures. However, these are less significant, so the summary for this learning objective is together these proxies enable scientists to reconstruct Earth's climate over a range of timescales, from the past century to the past hundreds of millions of years. They show that the climate has always changed, but also provide a baseline to detect how anthropogenic climate change differs from natural variability. So for the exam, be prepared to recognize and describe different proxy types and understand what kinds of data each method provides. A well-informed climate professional should not only understand just where we are today, but also how we got here.